All right, welcome everyone. So in this video, I want to define what an elementary matrix is, take a look at a couple of examples, and then think about how we can find the inverse for an elementary matrix. So an elementary matrix is a matrix that performs a single row operation on an identity matrix. So for example, this matrix E1, E standing for elementary, is applying one row operation on row 2. In other words, we're going to scale row 2 by 5. So that is one single elementary row operation. We can apply these operations in higher dimensions, and we can apply other types of row operations. So for example, E2, which is this 3 by 3 matrix. So now we're in R3, top row 1, 0, 0, second row 0, 1, minus 2, and the last row 0, 0, 1. This is an elementary matrix, and the operation that it is going on right here is replacement. Right, we have replaced row 2, so I'm going to write row 2, okay, is now equal to row 2 minus 2 times row 3, right? And that's where this minus 2 comes from. Okay, so notice this elementary matrix, row 1 hasn't changed, row 3 hasn't changed, so the only change that this matrix can be applying would be some change to row 2. In this case, we've replaced it with 2 times row 3 plus row 2. And the third type of elementary row operation that we can have is interchange of two rows. So you can see that this matrix E3 looks almost like the identity matrix, but we've applied one change, namely we've interchanged rows 2 and 4. So this would be an interchange. With rows 2 and row 4. So each of these is applying one individual elementary row operation. We call these elementary matrices. So let's first think about our notion of inverses as, okay, we want to undo the operation that the elementary matrix has done. So we looked at this first scaling operation on the previous, one of the previous examples, and we said, okay, if we want to undo a vertical expansion by 5, then we do a contraction by 5. And here we can think about, well, if I want to undo scaling row 2 by 5, instead let's scale row 2 by 1/5, right? So the inverse of multiplying by 5 is dividing by 5. And when it comes to replacement operations, the way I'm going to undo a replacement operation is by doing a similar replacement, but instead of subtracting 2 times row 3, to undo subtraction by 2, instead we add by 2. So in this case, the inverse is going to be a replacement operation on row 2, so we're not going to do anything to row 1 or row 3. And now row 2 is going to be replaced by a positive 2 times row 3 plus row 2. And for the last interchange, what I called matrix E3, to undo interchanging rows 2 and rows 4, we're going to interchange the same exact rows back. So we're not going to do anything in rows 1 or row 3, but let's interchange rows 2 and 4 again, and that would put things back in order. So notice here we have this special case that the inverse matrix of E3 inverse, is actually equal to E3. So the inverse of E3 is itself. So here we've got 3 elementary row operations, and by being able to identify what operation the matrix is applying, then we can find the inverse by thinking, how could I undo that operation? And where we're heading next is we can think of any matrix, any square matrix, as the result of applying a whole series of elementary row operations. So what we are going to try and do is see, well, what happens if I take all of the inverse operations in the reverse order? Is that going to give me an inverse matrix?